As I've already told you, this is an introduction lecture of operating system, and these slides are already there in your team. There is a files tab in your team, and you can see your slides already uploaded there. Now, what are the prerequisites for this course? We'll be using lots of C programming examples to make you understand the basic concepts of operating system, and our laboratory exercises are going to be based on C programming essentials. So please brush up your ideas about C programming. Computer organization essential are very much needed, because as you people have defined that this is an interface between a user and a system, or a user or a hardware. So the concepts of computer organization are very much needed. And what is the next prerequisite? It's lots of curiosity. You need to be curious about the system, about how stuffs are working. Uh, you might be using lots of computer system, your smartphones, your laptops, your tablets. Uh, so the better way to start knowing the thing is keep asking question, that what is happening, how the things are happening, and why these are happening in this manner. Just Google it. Suppose somebody asks you a question, what is the meaning of capacitive touch screen, or how this optical mouse work, uh, what is there inside USB, what do you mean by flash memory and magnetic memory, what is optical memory. So these are the things we think that we know. We think that we know about these things, but we may not be knowing it properly. So just take up your laptop and see the things and ask question. Whatever you are doing on laptop, ask question that how these things might be working, what is going on behind the scene. And in this way, you develop curiosity regarding the things. And obviously, you'll be in a better place. You'll be more confident about the things. Uh, Now let's start. That suppose I say that if a program is running, when a program runs, what happens? It simply executes the instructions. We know that. Many millions of instructions, even billions these days, every second. That depends upon what is the programming or what is the computation capability of your system. I have to take this call just a minute. Sorry. So it simply executes the instruction, millions, even billions of instruction every second, depending upon the computation capability of your computer. Now, what is happening? You have covered all these things in computer organization. What is happening when a program is running? So obviously you write your program in high level language, and then it gets converted into assembly language or machine language using assembler or compiler. And then this program is stored line by line in memory. Every memory block is going to have an address. So processor fetches lines of instruction from memory. And as you know, the meaning of instruction, to know the semantic of the instruction, there is a decoder over there. So that instruction is decoded to figure out what this instruction is going to do, or what is this instruction all about. Then depending upon the meaning of that instruction, the what that instruction is going to do, that instruction is executed. For example, it can be add instruction, or checking the condition instruction, jumping to another location. It's a for loop kind of thing, or a go to kind of thing, whatever. Depends upon what that instruction is, you execute it. And then after doing these two steps, you move to the next instruction. And you repeat this until program finally completes. How to go to the next instruction? You know that there is a register in your computer architecture known as program counter, and program counter always stores the address of next instruction to be executed. These things you have covered in computer organization. And as a matter of fact, what actually I have explained very briefly, this is known as von Neumann model of computing. This you have covered in your computer organization. Fine. Now, what is operating system? Now, while a normal program runs, there are a lot of other wild things which are going on. And the primary goals of those wild things which are happening in tandem with your program which is running is to make the system easier to use. Now, this is my own definition, the next bullet. So what I say, operating system is nothing but a body of software, is a bundle of softwares, which makes programs of user or application programs easy to run. And actually, Miss, you know that there are many programs which are running at the same time. Now, this bundle of software assists you in doing lots of things. It allows your program to share the memory, interact with your keyboard, mouse, and lots of other fun stuff. So what is an OS? OS, simply stating, you can say that it's a group of programs which are there to help or to assist a user program or application program to run. It creates the programming or running or execution environment and provide all those things which is needed by a user program or an application program. This is what is, you can roughly say, the definition of operating system. Now, when we talk about a system, there are always abstraction layer of the system. Like when I'm interacting with you using MS Team, everything else is abstracted from me because I only know how to use this MS Team, how to connect, how to join the students, how to set up a meeting, how to make a call. So I'm interacting using this MS Team application with you guys. And right now, I'm not thinking about how this program is executing MS Team, how the messages is getting transferred to the other end, how my voice is getting converted into digital data, and you people are sitting at different places. I'm not thinking about that thing. I just know what this application does, and I know the interface of this application. And for me, right now, my computer is a video conferencing device where I can share my slides, I can talk to you, I can teach you, I can take your question, so on and so forth. And then below, there is your computer architecture. A computer architecture or computer organization is again an abstraction. Because the way you have seen your memory, your AND gate, or your program counter register, or CPU, or memory management unit, or ALU, they don't look like that. When you study computer organization, you study at block level, that there is a memory block, there is a processor block, there is a ALU block, and they interact in some manner. So this is another abstraction. Actually, everything is getting implemented by very large scale integration devices, and finally they are transistors. So at the lower level, you see that there are semiconductor transistors which are getting fabricated into a chip, and there can be when we talk about very large scale integration, 2 to power 21, 10 to power 21 transistor per uh, millimeter, or maybe even less than that. So they say that on a needle point, they can fabricate 10 to power 20, more than 10 to power 21 transistors. So at the lower level, you have this transistors. There's one abstraction layer of computer organization. You interact with your system using your application programs. Now, where is operating system? Operating system sits in between these two abstraction, computer organization and application. And this is what is our focus of this course. Now, this is your computer system architecture. And this is how, Miss, you might have studied from different book. I've taken this figure from internet. Uh, this is how your computer system architecture looks like. So there is a display unit, monitor, there is a keyboard, there is a printer, hard drive, then how to interact with hard drive. There is a hard disk controller, then USB controller, keyboard controller. There's again semiconductor devices, video controller, your main memory, fine RAM, which we say, then your CPU and memory management unit. And all these things are connected by bus or a small network or on your motherboard. So on your motherboard, there would be interconnection among all these hooking points where memory, video control, and all these stuffs are there, and then your devices are connected. So in this way, you visualize actually the computer system architecture. Now let's start with a very simple program. Anybody want to ask at this particular point of time? Any questions from anybody at this point of time? Yeah, Abhigyan, anything you want to ask?
No, sir.
Okay. Okay. So let's start with a very simple program. And this program is nothing special about this. So it's a hash include stdio.h, including a header file, standard input output. Then there is a main program. So a string is hello world. And we are using a function, standard input output library function printf, which is printing the string on the monitor or on your display. So what is the output? You know what is the output? It's a hello world. How the string is displayed, that's an interesting thing. How this string is going to be displayed. So let's elaborate a bit and see how the things are going to be. So your program is, now let's start from the beginning. Fine. So I've given you this small program. So let's ask Gyan Ranjan. So I want to run this program. What should I do?
Yes, sir.
I want to run this program, the program which I have shown.
Hello,
What
world.
should I? Yeah, hello world. What should I do?
Compile and run.
No, first of all, you need to type this program, no?
Yes, sir.
So where would you type this program?
In ID or in any editor with
So
then we can
where is the editor?
in if we speak about Unix system, then we can have VI editor or
Where it is? VI editor is a program, no?
yes, sir.
So where is this program?
In the memory also.
It may not be in memory because
In the
in memory you keep the things which are needed. Means you need to run some program, you need to bring back the things into memory. Otherwise, where this Vim or VI or gedit would be
Yes, sir. Yes, sir,
in the
sir.
in the hard disk, no? In your
Yes, sir.
partitions.
ROM, yes.
Yeah. So where in the hard disk?
In memory blocks,
What is the address of that?
I don't know, sir.
No, you are getting my point or not?
Yes, yes, sir.
So right now, what you do, just write gedit ampersand, your uh, editor will be open. You just write vi file name, your editor will be open. Fine. But there is a whole lot of thing which is needed. So editor might be in main memory, might be in hard disk. So you require some different program to do this job for you. Are you getting my point or not?
Yes, sir.
When you double click something on your desktop, so whole lot of processing is involved. So you are double clicking an icon, or you just writing or firing a command of vi or vim. So that vi editor program need to be copied back into main memory if it is not there, and then it has to be executed, and then only vi editor will be open for you to type the program. You got my point? You are not doing anything.
Yes, sir.
Now, so suppose you have typed the program. Now, what else? What next?
And then we compile.
You have to save it, bacha.
Yes, sir. Yes, sir.
So you have to save it. For you, you are saving in your directory, in your current directory.
Yes, sir.
So you think your image of storage is like some my document, some folder slash this, or some this directory slash this directory slash this directory, and you are saving in your current directory.
Yes, sir.
But that is just an abstraction provided to you. That there is a C drive, D drive, this folder, that folder, subdirectory, and all that. So program, when you save a program, that has to be saved into hard disk. So how your path where you are saving the program is actually going to be translated into the hard disk address. Do you bother about this?
No.
Now I think I am able to push my point forward. That to write a program, then to save a program, you require some another program for your assistance. Are you getting my point or not? Abhigyan.
Yes.
Fine. So now what is the next stuff? After saving the
Then,
program,
then we'll compile.
you'll compile it. So again, the same question, where is the compiler?
Yes. It will
Com
be on maybe on.
Compiler is another program which you need to execute. Compiler is a special program which takes as input another program and create machine language program. Compiler is a program which takes a program in one language and convert that program into another language. Okay, so you require this compiler program also to be executing. So where is that compiler you need to bring back into your workspace, that is main memory. Clear?
Yes, sir.
Okay. Now after you do the compilation doing GCC and all, you will be you are ready to run that program. Now that compiled program, instruction by instruction, is stored in main memory, and now CPU will fetch that program, and that's what is there in the slide. Here. So in processor memory, the program would be there in your memory. So instruction by instruction, see the mouse pointer, or let me use the pen if I can. Let me see whether it is working or not. Pointer, ballpoint pen. So how the things are going to happen. This is your processor memory. So the program from processor memory will go to your processor. Now from the processor, it will go to your graphics card. And this graphics card will interact with monitor to display the things. And there is a whole lot of issues involved here also on monitor, that where on monitor, on which line, what pixel, where it would be displayed, things like that. So before actually able to run the program, lots of steps are needed. And then this program will be traveling and then again getting it displayed. And what you do in reality, you just write printf and whatever you want to print, and rest your work is done. Now that's what is written in the next bullet. It's a complex stuff, and it's hardware dependent too. As you can visualize now, without operating system, you need a program at every step to do all these complex steps one by one. So that's why I said in the previous slide, when I said, see this, it's a body of software which can be termed as operating system, which gives a platform or provides a platform for other application programs to run. It allows programs to interact with devices and other fun stuff. Any doubts or questions here? Or any comment? Now let me ask something from you people. Let's pick up any name. Uh, Aman Singh, are you there?
Yes, sir.
So, what is this printf?
So printf is an inbuilt function in stdio, standard
STDR.
input output.
So, what it does?
Sir, it actually means whatever the stuff that we put inside it in the form of string, it will simply put it like that. Otherwise, if we use the typecast like integers or the things like that, then it will print it like that.
Got that, got that, got that. But you are expected to do all these things. See the slide.
Yeah, yeah.
So, whether printf is doing all these things, transferring your hello world string to processor and then to graphics card to monitor, printer is doing
So
this thing.
so
Printf
printf
is
is
doing.
just a function. Printf is just a function in the background. So OS is doing all this, means
So
managing all these things.
so printf might be interacting with OS, no?
Uh, yeah, in some way.
Yeah, you are right actually. Printf must be calling another program to do all these things. So that
Yeah,
another program would be the operating system program. Now you're getting my point?
yeah, yes, sir.
Printf must be making a call to a routine or to a function of operating system or a group of function of operating system to do all these complex tasks, transferring your hello world string from memory to processor to graphics card to monitor.
Yes, sir.
Now, what actually it is happening? You are calling a library routine. Fine. Let
Okay, sir.
let me take this call. Got the point?
Yes, sir.
So printf is a library routine. Fine. So
Yes, sir.
you are calling a library routine and your work is done. So this is abstraction provided to you. That is known as Application Programmers Interface, API. And that's why
Yes, sir.
you include a header file over there, stdio.h. So you are calling printf, and now that library routine, printf is defined there in stdio.h. That printf, if you see the code of printf, that printf must be calling a operating system routine, must be making a call to the system, and that's why sometimes we say this is a system call.
Yes, sir.
And there has to be a routine or functions in operating system to do the job. And those are open also, so that printf can include or make a call to operating system. So there is another interface that is known as system call interface. So for you, there is a library routine interface. For library routine, there is a system call interface. Fine. And then
Yes,
OS
sir.
comes into picture. Are you getting my point or not?
Yes, sir. I'm getting it.
Okay. Now, you means everybody is getting or not?
Yes.
Rajendra, it's
Yes.
okay?
Yes, sir. Yes, sir. It is okay.
Okay. So let's move ahead. Let's move ahead. Now, whatever I have spoken is there. So application uses printf. Fine, see the mouse pointer. Printf makes a system call. So there is a file known as a standard output. It will be written into that file. Operating system uses device driver. So whatever is written in the standard output file will be transferred to device driver. And then this device driver again contacts with the display controller, and the display controller lets you write hello world on the screen. So this is where you can see here operating system is working. This is where is the role of operating system. Device driver, once installed, once you install the device driver, they become part of the operating system. Now, what is happening? Programmer needs to write the applications only without knowing the underlying details. And that's what is the job of programmers. If they keep on engaging with the internal detail, they will not be able to write good apps. Application can you reuse the OS functionality. You have written some common set of program and made those program as a part of operating system. So what is an operating system? Operating system is some common set of program bundled together, which you know that are going to be utilized by different application. Now another thing is it provides you portability also. Because it's not like that you need to change your application once you changed your hardware. So there is a abstraction layer in between operating system and which is known as operating system, which deals with these things. Let's take one example. Aman, you are attending this class by laptop?
Yes, sir.
Okay. So your laptop is connected through a Wi-Fi router?
Yes, yes, sir.
In hostel, you might have connected your laptop with a Ethernet cable also?
Yes, sir. I have done it.
You have done it. So when you are running with Ethernet cable, you need to change your MS Team application. That okay, this MS Team application for Ethernet cable and another MS Team application for Wi-Fi. Is it that so?
No, sir. Sir, it works on both.
So now you got the point.
Yes, sir.
So your operating system becomes system dependent, and that's why when you install operating system, there are so many versions of Windows 10 or Windows 7 or then it's a 32-bit operating system or a 64-bit operating system. Are you getting my point or not? So
Yes, sir.
operating system is system dependent, what hardware dependent. And once operating system is there, your programs are independent. So you are changing, you are increasing your RAM, you are decreasing your RAM, you are changing your hard drive. That will not make any effect on your programs. And that's what is the another goal of operating system and another beauty of your layered architecture. You can change the lower layer without affecting the upper layers. Any questions at this point? Anybody can ask question. Okay. So let's move ahead. Now, generally, when you see, you'll be having few processors. Suppose I talk about the current system, it is having octa-core processor, means 8 processors. But if I show you my task manager, fine. So there are so many. If I go to more details, see how many number of processes are running. Can you see it? Abhigyan?
Yes, sir.
And my system is having only 8 processors. So many programs are running. Every program need processor or other hardware. So only one printer is going to be there. A limited amount of RAM is going to be there, 8 GB, 16 GB. Fine. Only one monitor is going to be there. So there is a situation where there are many applications and limited hardware. So operating system acts as a resource manager also. When to give resource to one application, when to take the resources, reclaim the resources and provide it to another application, so on and so forth. With a goal of optimization, that resources are getting utilized in an optimal manner. No process or program or application should starve. No process or application should get unfair deal. Fine. So operating system acts as a resource manager also. If we move ahead, what is the use of operating system? Biggest is hardware abstraction. Can anybody give me the example of hardware abstraction? Turns hardware into something that application can use. Another I have told you, resource management. Example of hardware abstraction. Yeah, Anchal Tiwari.
Yes, sir.
Can you give me the example of hardware abstraction?
So hardware is always abstracted. So, so if we need to print something, so we give the command, and like we need not to see the internal details of how the hardware is working. We just get the printouts.
Okay. Tanmay is raising hand. Yeah, Tanmay.
So let's say we are running some program which uses a higher level of processing. So we, like in my laptop, if I want to run such a program, I can ask the computer to switch the performance of my cooling fan from a lower power to a higher power, so that the
So that's
process
an
becomes.
interface. That's an interface, bacha. So to deal with that hardware, there are some buttons given to you. Yes or no?
Yes, yes.
So abstraction is entirely different thing. So, just read that line again. Turns hardware into something that applications can use. And you use this example daily. I have given the example today in the class also.
For printing on the screen. Yeah.
No?
So sensors
No?
that application use.
No, I'm afraid it's not correct.
There is optical mouse hardware abstraction.
No, 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 no. Do you know about your hard disk? Your magnetic hard disk, which is there in your laptop or desktop? Some might be having SSDs also. So if you see your hard disk, so there are tracks and then sectors and then cylinders. Yes or no? Aman? Say no if you don't know. Say no if you don't know about hard disk. Hard disk architecture if you don't know. So there is a read-write head which is moving, hard disk is rotating, fine. And the read-write head is moving in a linear direction, hard disk is rotating in a circular manner, and that's how you. And for every platter there is a head, and that's why you write to or read from the hard disk. Fine. But how you visualize your hard disk in your system? You visualize your hard disk not as the three-dimensional address that this is a track number, sector number, cylinder number. So hard disk, every block is having a three-dimensional address. You visualize your hard disk as if it's a root, bin, or as C drive / my documents / this / this / this. So for you, the storage is a structure, a tree kind of a structure. That is not real. That is not real. That's a virtual thing. Your directory structure or your folder, subfolder structure is actually the logical abstraction of your hard disk. Let me take another example. Aman, you said you connected through your Wi-Fi router, no?
Sir, actually no Wi-Fi means not like that. Means mobile hotspot using.
Okay. Anyway, it's like you have one interface through which your packets are coming, your voice and everything is coming. Actually, just tell me one thing. Have this ever happened to you that you are chatting with 4 or 5 fellows, one on Facebook, another on Gtalk, other on some other messenger, Skype, or this happened to you or not?
Yes, sir. This used to happen.
This used to happen because normally it's like you're chatting on Facebook, you're obviously with different fellows.
Yeah.
So, and you have only one interface from where the data is coming, no, or going.
Yes, sir.
So why these messages are not getting jumbled? Because they are coming to one destination.
Sir, I think there must be some scheduling process that makes it to work in a
Means there
structured
has
and a
to be
timed way.
there has to be some temporary storage somewhere, no, some buffer somewhere,
Yes, sir.
and every buffer has to have some identification also.
Yes, sir.
That this is the FB data of Mr. X, this is Google Talk data of Mr. Y, and something like that.
Yes, sir.
And then only you can recognize and arrange the things in a smooth manner.
Yes, sir.
For you, it is just like the right message, press enter, fire, done.
Yes, sir.
And there is only one interface, and that is known as Wi-Fi interface of your laptop. That is known as network interface card. Wi-Fi network, wireless network interface card. All the data is coming to that, and all the data is going through that. Okay?
Yes, sir.
Okay. So how many cores in your laptop? Is it octa-core, dual-core, or quad-core processor?
Don't know, sir.
That's what I have told you in the first or second slide, the know your system. Anyway, so right now my system is having 8 cores, but you can see more than 8 processes are running. Yes or no?
Yes, sir.
97 background processes. Can you see? 10
Yes, sir. I
instances
can see.
of 10 instances of Google Chrome, 1 Microsoft PowerPoint, 6 instances, 6 different processes of Microsoft Teams, Task Manager itself, and Windows Explorer. Okay?
Yeah.
And only 8 processors.
Yes, sir.
Now let me give you a situation. Fine. Let me give you a situation.
Yes, sir.
Suppose there is only one processor. Without loss of generality, let us take this example. Suppose there is
Okay, sir.
only one processor, and you are running a 1,000-line code. Say a C
Yes, sir.
program of 1,000 line.
Yes, sir.
You are currently executing. Suppose your processor is currently executing 300th line of that code.
Yes, sir.
Okay, 300th line of that code. And suddenly you double clicked another program.
Yes, sir.
So what will happen? Your system will say, just shut up. One program is already running. You are not allowed to double click it.
No, sir, not like that. Actually, it will be running that in the background means and
Background means
taking
what?
means it will be getting done. But when we double click on another program, it will get a schedule or we will put in a queue that it will be done after that.
But you
When
will
the
get the output of that double click, no?
yes, sir, we will get it.
And you will get the output of that double click only when that double click program is executed.
Yes, sir.
And if that double click program has to execute, so whatever is getting executed before has to stop, leave the CPU, because there is only one processor in this example.
Yes, sir.
Okay, you have double clicked, you have done your work, fine, and you close the program. Now what will happen? The program which was stopped at 300 line
Yes,
will
sir.
run. Yes or no?
Yes, sir.
So from where it will run?
So it must run from the 301st line and storing the result of previous 300 line.
Where? You have left the program. Damn it. You have left the processor. So when you have left the processor, so your program counter register, all the register, everything. Means you have seen, you have gone through these register and all those in your computer organization.
Yes, sir.
So your all the register of processor are going to be overwritten by next program. And the program which has left When it runs again, we'll be having no remnants over there because you have left the program. Yes or no?
Yes, sir.
तो फिर से पहली लाइन से चलेंगे.
Yes, sir. It is looking like that.
Now that's the challenge I was telling you. So you need to now again see this line. You need to convert your hardware into something virtual, something logical, something in software, something in data structure, so that application can use that hardware. Here processor is a hardware, no? One
Yes,
processor,
sir.
two programs. One was running but could not get completed because another has forced that program out of the processor. Now the first program which has left out again wants to run. It has to run from the same point. For that purpose, when a program is leaving, it has to take everything which was there in the processor so that next time it can regenerate the environment, same environment while it was running, because that environment will be overwritten by a new program. Cool?
Yes, sir.
And that something which does that is known as abstraction.
Yes.
That's something which actually takes the photograph or the snapshot of the processor when a program leaves and not completed yet, because there is every reason to believe I have to come again to execute. And if I want to come again to execute, I need to take my processor with me virtually.
Yes, sir.
Got the point? And
Yes,
that
sir.
is known as abstraction. There has to be something which can. How many of you are using virtual machines? Nobody? VirtualBox, VMware, Tanmay, yeah. Tanmay, Divyansh. Yeah, Upadhyay ji. Which software you are using for VMs?
Sir, Windows subsystem for Linux.
Okay. So your hardware resources are abstracted.
Yes, sir.
Okay. I think you have got the point now. So we'll be coming to this virtual machine and other things also in due course of time. Okay. So let's move ahead. Sharing the CPU. So the challenge is who uses the CPU. There are, say, 4 applications, app 1, app 2, app 3, and app 4. And now everybody wants to use. So the simple policy is give the first one. When first is completed, give it to second one. Then second is completed, give it to third and fourth. When one app completes, the next will start. So there is nothing like urgency or what. What will happen if one app is running, another app will be in queue, and once you double click, the system will tell you, wait, you are in a queue. Let the processor be free, and then you'll get a chance to execute. This is one way of doing this. A very old system used to work like this. Fine. Now what will happen? Suppose an app is running. Please be very careful. This is very important. The app is executing and suddenly in the code of app 1, there is a scanf statement. Now scanf means program requires what? Some input from user. Now user will provide input. Obviously, user can type in half of a second, seconds, and that's a very huge time for your processor because processor thinks in nanoseconds. So app 1 was running. There was a scanf statement suddenly in app 1 during the course of execution. So what will happen? User will provide the input, and CPU will be idle for that time being. Because the policy is until unless app 1 is completed, app 2 cannot come. So in older days, this used to be a biggest hurdle, that if an application is going for an IO means now the keyboard is involved. Or if app is trying to print something in the due course of execution, then monitor is involved. And these are IO operations. IO operations are way slower than the CPU operations. And during that time, CPU is idle for a very long time. This in turn reduced the performance. Now to avoid this, another type of support came in more advanced operating system, that if there are 4 apps, app 1, 2, 3, and 4, if app 1 is waiting for some event, we can fill this gap with app 2. But obviously, the challenges are more, because now app 1 has to leave the CPU, and once it has to leave the CPU, it has to take the CPU virtually with itself, so that app 2 can run. Fine. App 2 will run, app 3 will run, and then when app 1's IO is finished, app 1 can again get a chance to execute, so on and so forth. So in multi-programming, there are many programs in main memory, and many programs may execute at the many programs may execute where there may be many programs which have started executing but not finished yet. So the bottom line here is, when CPU is idle, switch to another application. There would be starvation in multi-programming, because if suppose app 2 is not a IO bound kind of process, app 2 is not doing any IO operation. Suppose you have utilized a infinite while loop, then this app 2 can hang the entire system because it is using CPU all the time. And another application will not get chance for execution. Because the rule here is multi-programming is that app 1 will leave the CPU only when it is going for an IO. And if there are no IO in app 2 can capture the entire system and app can hang the entire system. So nowadays operating systems are known as time sharing operating system, where the whole processor time is divided into small time slices known as time quanta. And each app executes within a slice. And that's how you get an impression that everything is running concurrently, even if you have one processor or less number of processors. So they will run 1, 2, 3, 1, 4, 2, 3. If they are going for IO, again another will come. But in any case, no app can utilize the processor in one go more than its time quanta, allocated time quanta. So this is known as multitasking or time sharing system. A program will run for some time slice is over, another program will get chance. A program is running, even if within a time slice, you see here, within a time slice, if it went for IO, another program will run, so on and so forth. So it all started with these simple type of systems, uni-programming, then multi-programming, and then finally the time sharing. So nowadays systems are time shared systems. And till now I have only talked about the processor as a resource. There are other shared resources, printers, keyboards, RAM, disk, files on disk, networks. Fine. An operating system takes care and manages all these resources. Nowadays, we have multiprocessors, multiprocessor chips in a single system. This is another type of architecture, bullet number 1, where there are many processors on a single chip, on a single system. Nowadays, we have multiple cores, many cores of a processor. There are difference. So this is due to the advancement of chip design technology. Nowadays, we can have multiple processors fabricated, multiple cores of a processor, which is equivalent to a processor in a single chip, multiple cores in a processor. And then we can have multiple threads in a single core. These are not your programming threads. These are CPU virtualized threads. Fine. So on a single chip here, you can see there are 2 cores and every core is having 2 threads. I don't know whether I can show you the configuration of my system. So if I see the property, you can see here. So I'm right now on a workstation. So this is a very big system. So we can see here processor is this, RAM is this, system type is this. Can you see the cores of processor? Vijayan, can you see?
No, sir. No, sir. It is not.
Okay, in Linux there is a command for knowing the cores. I don't
Yes,
know.
sir. In Linux, it is there.
So yes,
So you can go to Task Manager, and Task Manager will show.
yeah. From Task Manager we can see. So let me see. I can show you Task Manager. Where I need to go?
So performance.
Performance and
There it is, cores and logical processors.
where?
So yeah, right below there, cores and logical processor.
Yeah. So we have got 12 cores over here in this system, and every core is having 2 threads. Okay. So this is not your this thread. This thread is another thing. We'll be coming to this. Fine. This thread is a programmable thread, and this, when we say logical processor, is like a hardware technology, how a core can be represented as different thread. So that's what I want to push forward. So don't confuse this thread with the threads you create in Java or another programming languages. Okay. Fine. Now there is another problem. You keep on making advancement and you keep on encountering problems. Now the situation here is that at a time many programs may be running, may not be finished, but they are in execution. Some may be waiting, some may be actually executing, some may be waiting for one resource, another may be waiting for keyboard, another is waiting for monitor. But many programs have started execution. Now there may be a situation which is very much important to understand, and we'll devote a whole 4 or 5 lectures on this, which is known as race condition. Suppose in its program, app 2 wants to write something to the file. And in its program, app 5 wants to read from that file. Now, suppose at one given point, app 2 is writing into the file, writing is not completed. and this app2 is out of the processor due to the time slice. App5 gets a chance and want to read it. What will happen? You got the point, everybody? I'm saying there are two applications. One is running and want to write something to that, some memory location, say want to write something to that memory location, or a file, or a buffer. Writing is 2 or 3 instruction, 4 instruction procedure, writing something to a file or a buffer. So app2 was about to write into file. It has started writing, but could not finish, and app2 has to leave the CPU. App5 comes into the CPU and wants to read that same file. What is the problem here? Yes, Anurag Upadhyay. Divyansh, what is the problem here?
So the information that F5 wants to read was not even there. That is the main problem.
Maybe there, but in inconsistent state, no?
Yeah, it may be there, it may not be there.
It may not be there because you are not sure whether you have done the writing job completely or not. So what is the solution here?
So we tell the F5 to wait until the app2 has completed the
So
instruction.
for that purpose, we need to do something like this. For that thing, we need to do something like this. Lock the resource. Now the sequence of steps would be app X locks the resource, and until and unless app X unlocks it, app Y cannot use it. So if there is a race condition, you need to provide synchronization. And to provide synchronization, the method is very simple. When an application is about to use a shared resource, the question, the problem here will be apparent when there is a shared resource. The same thing, suppose two programs have fired a request on printer. Program 1 wants to print a PDF file, program 2 wants to print a Word file. Program 1 is printing an application of 3 pages, program 2 is printing an application of 6 pages. And there is only one printer. What should happen? Yeah, Upadhyay.
Answer processor, the operating system will tell that either one of them will print the whole thing, then
Yeah,
other will print.
obviously, whomsoever has gained access to the printer should lock that printer first of all. And once your work is done, you unlock it for others to use. And that's how you can provide the synchronization. The locks ensures that only one app can access the resource at a time. The sequence of step would be like this. Application will lock the resource, will access the resource, and until unless application X leaves the resource, application Y will wait. After doing its work with that resource, application X will unlock the resource. And now application Y can lock and access the resource. Got it?
Yes, sir.
Okay. You might not be realizing I'm slowly and gradually telling you the chapters of our course. That what? So I've started with virtualization, hardware abstraction, then race condition. Now the next thing is scheduling.
So
Yeah.
So, but which app will lock the resource first? Like, there should be some priority.
There is a race, no? There is a race.
Okay.
Depends upon. So the priority comes here, no? In this slide. Okay.
Okay, sir. Okay, sir.
But there may be a situation where there are 20 processes of same priority, no?
Yes, sir.
So then there would be a race, and then whomsoever wins the race would lock it. Yes or no?
Yes.
Got the point or not? You cannot have different priorities for all the processes. There has to be a group of processes belonging to some priority. Okay.
Yes.
So who should execute next is another pertinent question in front of operating system, and that is taken care by scheduling. So these are set of algorithms that executes to determine which app should execute next. First of all, it needs to be fair. No one process should get extra privilege. And at the same time needs to be able to prioritize some apps over others. So there has to be some application, there are going to be some application which are going to have higher priorities. So you can be having this power to prioritize some application over others. Fine. So there is a very brief detour, but I'll take this later on. Fine. So the detour I'm skipping for this class. In next class, we'll take that detour, or just tell me if you want me to take that detour, then this particular thing we'll take in the next class. Up to you. Okay, I'm more interested in this. As I told you that how OS performs its jobs. OS does this by virtualization. It takes a physical resource, processor, memory, or a disk, and transform, as I told you, transform into a more general, powerful, easy to use virtual form of itself. And if you watch it closely, OS itself is referred as a virtual machine. So those who are using virtual machine, they are doing nothing. They are running a complete operating system as a virtual machine using some VMware or VirtualBox hypervisors. How OS perform its jobs is by virtualization. This is one keyword. Another is how users and programs interact with OS. As I told you, you interact with printf interact with OS using a call to the system, and those set of calls are provided in a standard library, but that is not a user library. Your stdio.h is a compiler's library. Fine, a library which is provided to you by compiler. Fine, and at the same point time, OS provides you a standard library of application program interfaces or application programmer interface or APIs, which are known as system calls. Using these system calls, user program or user application can make a call to the operating system code. So if you want to run something from operating system code, you need to make a system call. More on this later. We'll be coming to the system calls later on. Resource management through virtualization. Virtualization allows many programs to run by sharing the CPU, concurrently access their own instructions and data, sharing memory, access devices, sharing disk, access printers, sharing this, and so on and so forth. So virtualization is a keyword. What is virtualization? We'll be discussing in a short while. Let's take this program. So Aman can describe this program. Can you describe, Aman, this program, what it is doing, line by line?
Yes, sir, I will try to.
Yeah.
Sir, initially, when the at the top of it are there are the some libraries which we will
Okay.
be using.
Okay.
Yeah, yeah. After that, there is a main function.
Okay.
Yeah, and for that we are taking two things. First one is an integer, and second one is
क्या कर
array of characters.
So why this is used here? This is for command line inputs.
Yes,
Okay.
sir. Yeah.
This is for command line inputs. Okay.
Yes, sir.
Brush up
For
your
command.
C programming. Okay.
Okay,
So
sir.
when you want to take inputs into command, so you use this. Okay.
Yes, sir.
Then
So
forget.
then, yeah,
Then it is checking whether arguments which are provided are
is equal to
less
two or
than or
not.
equal to 2 or not. If not, then it is printing an standard error message.
Yes,
Okay.
sir. Yeah.
Then doing nothing, you are whatever is in the first argument, you are
Passing it.
storing it into a string,
Yes, sir.
and then in while loop there is a sleep of 1 second. Okay.
Yes, sir.
And then you are printing that in string. So
Yes,
nothing
sir.
special here actually. So when I run this gcc minus o, this is CPU is an object file, and then CPU1. This I have stored this program as CPU1.c,
Yes, sir.
and when I run this dot slash CPU and provide a input a character or a string, it will print this in string. And how? After every 1 second, it will be printing. Let me see whether I can share my virtual box with you guys or not. So I have done some uh, tweaks here. This is my Ubuntu virtual machine, and if I can you see the settings here? Is it visible? Is it visible
Yes,
Yes,
to
sir.
yes, sir. Yes.
everybody? Yeah. So if you go to the advanced, in general advanced, uh, what I have done, if you go to the system, what I have done, I have assigned only one processor to this virtual machine. Everybody got this? Means this virtual machine is running on single processor. So I just wanted to create an environment of uniprocessor operating system. That's why I have assigned only one CPU to this virtual machine, this Ubuntu virtual machine. Got it, Vijayan?
Sir, yes, sir. Got it.
Okay. So let me run this VM. So I've already written these programs, this program, and will show you the output of this program. Just wait, may take some 2-3 minutes because it is running on one processor. Meanwhile, if there are any question you can ask, anything up till now, you want to ask anything. Anybody?
Answer one trivial question.
Yeah.
You said that we can use the operating system on any
Mm-hmm.
hardware.
Mm-hmm.
So why is that we cannot use Windows on Mac or vice versa? Is there something specific?
Because Windows haven't created for the Mac machine.
No,
But you can
but
But you can always run Windows using a hypervisor over Mac machine. I don't have right now, but maybe in next class I'll show you on my MacBook. Windows is also running as a virtual machine.
Then how is it doing that? I mean, then we are also using the. You said that virtual operating
So
system is a
right
virtual
now
machine.
what is happening? Right now what is happening? Linux is running over Windows, no?
But we are using the hardware, right, through virtual machine.
We are not directly using the hardware. That's the beauty. Fine. Because this machine is having one hardware only, and that is getting utilized by your Windows. Fine.
Okay.
So you are virtualizing that hardware for running that virtual machine of Ubuntu. That's what. Fine. Uh, उपाध्याय जी थोड़ा थोड़ा सा पेशेंस रखें, ठीक है? मातृभाषा में बहुत गहरी नदियां है ये, ठीक है? ऑपरेटिंग सिस्टम, ठीक? धीरे धीरे आएगा समझ में. एनी अदर थिंग? या तन्मय, एनीथिंग यू वांट टू आस्क? तन्मय धवन? Okay.
No.
Okay. Nishant Rai?
No, sir.
Okay. So see, my Ubuntu is booted as a VM. I have already created this program. Fine. So let me see. Let me show you the output of this program. Fine. Vision, it is visible?
Yes, sir.
Okay. So first of all, let me show you the program. This is the program that was in the slide. Okay. So taking a character, sleeping, and then done. So let me compile it. And now let me run it. Okay, I have to provide a string. So after every 1 second, A is getting printed. I've shown you this just to show you the usage of that standard error message, which was there. We have used. If argument is not equal to 2, then usage CPU string. Got the point? So you can see here, nothing is special. A is getting printed. Now let's see. Let's see dot slash CPU A and So let's see what is happening. Can you see the output? There's only one process.
Yes, sir.
There's only one processor. I have run 3 processes. All are running. Yes or no? BCA, BCA, CBA, CBA. Order is also changing. Any comments from anybody? Any comments from anybody?
Sir, why is the order changing?
So why is the order changing?
Think over it. See here, we have given 3 processes, same processes. Same are having same code. Which code? I have shown you. This code. In a while loop, sleeping from 1 second and printing the screen. So if suppose first process went printed A, slept. Second printed A, slept. Third printed, second printed B, slept. Third printed C, slept. So from your point of view, it should be A again. That's what you are saying? Yes, Aman. Abhiraj.
Yes, sir, it should be A again. Means if
But A is sleeping, bacha. The matter of fact is, it's not in your control. It's dependent upon which scheduling policy or how CPU is scheduling these processes. But that's not a major point here. Major point here is something else, which you guys are missing. There is only one processor. And all these 3 programs, even with only one processor, all these 3 programs seem to be running at the same time. Now, actually, what OS is doing, even if there is only one processor, it gives you an illusion of very large number of virtual CPUs. That is the virtualization I'm talking about. This turns a single CPU or a small set of them into a seemingly infinite number of CPU. And allows many programs to seemingly run at the same time. They are not running at the same time. C, B, D, A, C, B, D, these all are running because only one processor was there at a time. Only one process can run. But when one process was running, it went for sleep, context switched to another process, went to sleep, and you think that there are many processes. होना क्या चाहिए था तुम्हारे हिसाब से? Damn it, it's a while one loop. If one process have taken control of CPU, it should have printed A all the time. Yes or no? Because it's a while loop. But as soon as inside a while loop, something went for sleep, its CPU is idle. Another process got a chance. Another got a chance. Another got a chance. And you get an idea, you get an illusion that there are many processors and seemingly every process is getting executed. Any doubts? Abhiraj?
No, sir.
Okay. So I think let's stop here. So otherwise would be a huge dose for today. Let's stop here and just think about the today's lecture. Think and you can always see the videos later on. And it's not only about studying, it's about thinking that how things might have been happening. Fine. So whatever we have discussed, just go and just give some time to this and you'll understand and hopefully you'll enjoy also. Are there any questions? Any questions from anybody?
No, sir.
No, sir.
Okay, so I think day after tomorrow is your first lab. Brijend, any question?
No, sir. No, sir. So lab is on, sir, Wednesday or Thursday, sir?
A lab is on Wednesday.
But sir,
Wednesday,
in
3 to 6.
yeah, sir. In mail, sir, you have written Thursday, so that is why I was asking.
I'm sorry.
Okay,
बच्चा
sir.
लोग क्या लिखा मैंने मेल में? थर्सडे लिख दिया क्या? थर्सडे लिख दिया था क्या मैंने? ओ हो सॉरी बच्चा लोग. Sorry. It's Wednesday, huh?
Okay, sir.
So lab is on Wednesday. You might be having timetables. Aman?
Yes, sir.
Okay. Any questions?